Hi everybody, this is Julian from Arcee. A couple of hours ago, the Hugging Face LLM leaderboard was updated, and we're really happy to announce that our latest 8 billion parameter model, called SuperNova-Lite, is now officially the best open source 8 billion parameter model available. It sits at the top of the leaderboard. That's great. So in this video, I'm going to show you how you can deploy SuperNova-Lite, which is a llama 3.1 model, on Amazon SageMaker, and I'm going to use the Inferentia2 accelerator to do this, because this is super cost effective, and in fact I'm going to use the smallest Inferentia2 instance available, which costs about 75 cents an hour. Yes, you heard that right, not $75, 75 cents. So once you've watched this, you'll be able to run what we think and what the leaderboard thinks is the best 8B model available today for under $1 an hour. Sounds good? I'm sure it does. Let's get started. As a reminder, about a week ago, we released Arcee SuperNova, our new 70B model, which is competitive with the largest open source and closed models, including Claude 3.5 and GPT-4, etc. And I did some videos on that, and you can find them on the channel. There's also an 8 billion version of this model, and this is the one we're going to work with today. And this one is called SuperNova-Lite. Actually, llama 3.1 SuperNova-Lite, because this model is based on the llama 3.1 architecture. So this is the model page, and you can read a little bit about the model. And in a nutshell, this is a distilled version of llama 3.1 405B, a much larger model. But apparently we're able to keep a lot of the original goodness into the much smaller 8B model, right? And you can go and look at the evaluations. And of course, I have to show you the leaderboard, right? And as usual, all the links will be in the video description. So here I'm showing you all the 8B models. You can see them here, right? Size 8B. So all of them, the base models, the fine-tuned variants, and we are number one, right? Which is quite nice. And we are even outperforming 9B models. Pretty cool. So well done, team. SuperNova-Lite, the best 8B model available today. So now let's see how we can deploy this. Recently, I did another video on the developer resources that I built to help you deploy our models, and in fact, I would say Hugging Face models in general on AWS, so notebooks, CloudFormation templates, etc. And of course, I'm going to use one of those notebooks to deploy our SuperNova-Lite model, right? So if you go into that repo, you'll see two notebooks. There's one for GPU deployment, and there's one for Inferentia2 deployment, and that's the one I'm using today. Okay, so let's jump into that notebook and see how things work. Here I'm running this notebook in SageMaker Studio, but again, you can run this in any Jupyter environment with your AWS credentials. Okay, so let's just go and look at the different steps. So dependencies, importing some packages, and you can see here I am using the DGL inference server. And I believe this is the first time I'm showing you this, because so far I've been deploying on SageMaker using the Hugging Face TGI container. But I've found that for devices like Inferentia2 and Trainium, so the so-called neuron devices, they're called neuron devices because that's the name of the accelerator on those chips. For those neuron devices, the DGL container is actually a better choice. It supports more models, and it's officially supported by AWS, so I'll recommend this one. Again, you can read all about it in the DGL documentation. I'll put all the links in the description. They have this large model inference container, which supports different backends like VLLM, TensorRT, and as we can see here, of course, the Neuron X devices. Okay, and the documentation is pretty good, and well, you should be able to figure it out, right? And this is again all the doc and all the supported architectures for that NeuronX backend in that LMI container. Okay, so this is what I'm using today, and let's just grab well, SageMaker client, SageMaker buckets, the usual stuff. So in this notebook, and in general with Inferentia and training devices, you can deploy models in two different ways. The first one is to download the model either from the Hugging Face Hub, or load it from an S3 bucket, but load the vanilla PyTorch model and compile it on the fly. And that container can do that. There's nothing to set up particularly. So that's option number one, and we'll look into that. And that's the one I'm going to use today because it's really it's the simplest way. But compilation takes a few minutes. So option two would be to load a precompiled model. Okay, and the notebook has some instructions and pointers on how to do that. This is a slightly more involved process, but the benefit is obviously that you save the compilation time, right? So here we're going to go with option one. So download the model from Hugging Face and compile it on the fly. Okay. If you're interested in the second option, I found some pretty good instructions in the DGL website on how to compile and package. So if you follow that, you should figure it out. I did. And I guess I'll do a specific video on that compilation and packaging process. It's not as bad as you think, right? You just need to follow the steps carefully. So anyway, today we're not going to do that. We're going to load the model and compile it on the fly, and it just takes a few minutes, as you will see. And of course, because we want compatibility with the OpenAI API, we enable that, right? And that's actually available out of the box in that container. So that's pretty cool. We can just use the OpenAI prompting format. Now let's look at the configuration for the endpoint. So as mentioned, I'm going to use Inf2XL, which is the smallest Inferentia2 instance available. So it costs 76 cents an hour on EC2 and 99 cents on SageMaker. Okay, so and that's on demand price, of course. So you can optimize that if you're a Neobus customer. You have larger instances available, but for a model, in the 7 or 8B range, my tests show that you really don't need to do more than Inf2XL. And if you need more throughput, you can just scale out on Inf2XL instead of trying to scale up to Inf2 24XL or 48XL, etc. The model is really honestly too small for those larger instances, and you don't get really nice linear scaling. So again, my option would be start on Inf2XL and scale out your endpoints on that instance type, right? Okay, so pretty simple. Then we just need to grab the name of that nice DGL NeuronX container. I believe there's a new version coming out momentarily because there is a new release of the Neuron SDK that just happened. You can see here I'm using SDK 2.19.1, and 2.20 came out literally yesterday. So hopefully we'll see upgraded containers very quickly. And generally they tend to bring speed ups and a bunch of new features. So excited to try this one out when it's available to everybody. Okay, so now that we have the instance type and the container, we just need to go and define how to load the model and how to compile it. Okay. So the model environment is obviously here DGL specific. If you watch some of my TGI videos, well, these are different environment variables, but they tend to define the same things, like the tensor parallelism degree. So on this Inf2XL instance, We have 2 neuron cores, okay, the accelerators. So we set tensor parallelism to 2. I'll set batch size to 2, sequence length to 8K, and well, that's pretty much it, right? And remember, because we are compiling the model, we do need to work with a fixed batch size and a fixed sequence length, right? But of course, we'll use padding and everything else. And that's also why I think compiling on the fly is a really good option when you're experimenting and you want to try out, throughput and latency with different batch sizes and different sequence length, etc., etc. So if you compile on the fly, you can try really quickly different things. You don't have to pre-compile models only to realize, oh man, okay, no, batch size is too high or is too low. Now pre-compile, repackage again, etc. So long story short, I would recommend on-the-fly compilation for dev and test and experimentation. And once you've locked in your configurations, then pre-compile and run deployment from the pre-compiled artifacts to speed things up. Particularly if you have auto-scaling configurations. I mean, you don't want to recompile the model on each auto-scaled instance. It'd be annoying. Okay, so here we're just going with those parameters. Then I'm defining the DGL model object, so the model ID, right? And remember, model ID is our SuperNova-Lite model from the hub, the name of the container, the environment, and the SageMaker role. Okay, and that's all there is to it. So really, really not difficult, okay? And as the notebook says, once we've done that, we can create the endpoint. So let's just do that. We'll skip the pre-compiled section and we'll come back to that, in a future video, maybe once the new SDK is fully integrated. So then it's really just a matter of calling deploy on that model, okay, with the instance count, the instance type, endpoint name, blah, 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 blah. Small gotcha, you need, on inf2 instances, you need to add, you need to attach an EBS volume, like so, because unlike P4, P5, and I think TRN1 instances, inf2 doesn't have instance storage. They have a little bit of storage, but even with an 8B model, there's just not enough to download everything and copy everything. So your endpoint deployment fails, and you'll see no space left on device in your CloudWatch log, and you have to start all over again. So here, 64 gigs is more than enough. Okay, and we're on deployment, and it goes for 17 minutes. So why don't we take a look at the log to see how long the different steps took. Okay, so I'm looking at my endpoint in the SageMaker console. If I click on this and then on logs, I'm gonna go to CloudWatch and I'm gonna see the log for this. Maybe let me zoom in a bit. Okay, so my timestamp tells me when this was created. So it was created at 12:12, right? So instance starts logging at 12:19. We have 2 neuron cores, blah, blah, blah. We see DGL starting, a whole bunch of messages here that we're not really interested in. And okay, so now we see the model being loaded, right? Okay, loading model at 12:19, 14 seconds. Right, so it's downloading it from the Hugging Face hub. So that took about 3 minutes. Okay, a little more than 3 minutes. And then we see compilation starting at 12:22:37. And it's done at 12:28:39. So yes, is that 6 minutes? Yeah, 6 minutes. Okay, And that's not too bad because the Inf2XL instance is really, really tiny. It has a handful of vCPUs. So if we deployed, let's say, on Inf2.8XL, which has the same number of neuron cores but more vCPUs and more RAM, it would certainly compile a little faster. Okay, but again, you don't need more. This is you know, you need to go small and cost effective. Okay, so if you're running the precompiled deployment option, you should be able to save, let's say, you know, 6 or 7 minutes. Okay, that's what it looks like. All right. Okay, so now let's go back to the notebook. Okay, so total time 17 minutes, right? With the precompiled option, probably, I don't know, 11 or 12, right? Which, you know, doesn't sound like a very nice improvement, but again, if you're auto scaling, you know, 6 minutes is very significant. Okay, so now we have a running endpoint, so we can start running inference. Okay, so let's first start with this prompt. Okay, let's get names for pet food stores. And here you can see I'm using the OpenAI format, so the system prompt, the user prompt, and of course I can pass all the usual parameters like max tokens, etc. And here I'm not using streaming. Okay, so invoking the endpoint is super simple. We use the Bodo3 invoke endpoint API, which is passing the endpoint name and a JSON string with the payload, right? And again, we deserialize and print the output, and we can see we get the OpenAI output format, right? With the content, blah, 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 the number of generated tokens, okay? And you can see we generated 339 tokens in 15 seconds. So that's about, yeah, maybe 24, 25 tokens per second, which is pretty good, especially given the price point of Inf2, right? We could display, because it did generate markdown, right? We can print the markdown for a nice answer like that, okay? And we can try another one. Let's try a marketing email, right? Write a marketing pitch for a SaaS platform called RC Cloud, etc., etc. Right? I guess more of a real life scenario than the pet food store, unless you want to start a pet food store. Okay, again, 1024 tokens, no streaming, exact same code, and we get our answer, right? And it's inserting emojis and everything. I mean, we could say, well, no emojis, you know, keep it serious, etc., etc. But you can see how easy it is to prompt, and those are very simple prompts, right? And we get really, really good quality answers because the model, you know, started from llama 318B, which is already very good, and then our team made it way, way better. Okay, now let's look at streaming. So how do you do streaming? It's not much different. In your payload, you need to set streaming to true. And instead of calling invoke endpoint, you need to call invoke endpoint with response stream, and you're going to receive a streaming object. So the slightly tricky part is how do you process the data coming from that streaming object? But in the repository, you'll find utility code to do that. And I've showed you this before, I think. This comes from an AWS blog post from a while ago. So I just adapted it a little bit for the OpenAI format. So now we just have to pass the response body and call this function, and we can have a nice streaming answer. Let's see that. There we go. Okay, so now we have something that looks like a chatbot. And we can see the speed is more than adequate, right? I can't read that fast, and I think generally anything higher than 10 tokens per second is fine. You can't really read that fast. So here we're probably at 24, 25, maybe a little more. and this is really nice, right? And just the last one, maybe a customer email for a motorcycle enthusiast named Julien with a couple of bikes. And here, I try to provide a little more context to see what the model can do here. Right, so maybe write personalized emails for your customers, injecting context that you would retrieve from, your database or your RAG or whatever, right? And it's a really good writer, I have to say. It's a really good writer, right? And you can try it with all kinds of things. You can try, code generation, code explanation, code debugging. I mean, all those things work super nicely. And once you're done, please, 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 as usual, don't forget to delete the endpoint and avoid unnecessary charges, right? And if you want to be 100% sure, just go back to the SageMaker console and yes, the endpoint is gone, okay? It's not expensive, but you don't want to pay for things you're not using. Right, well, that's really what I wanted to show you today. So to wrap things up, really, really excited about this SuperNova-Lite model, the best 8B open source model available today. And you saw how straightforward it is to deploy it on AWS for under $1 an hour. And again, that's the on-demand price. If you're an AWS customer, you can easily optimize that in different ways. So the best 8B model with really amazing abilities. And this will be more than enough for a lot of use cases for under $1 an hour, right? And no code to write because I wrote it for you, right? I hope you like that. Well, that's it for today. Thank you very much for watching. And there's much more coming with Inferentia and everything else and more models. There's always more. So until next time, my friends, you know what to do. Keep rocking.